Applications of trigonometry. This is a worksheet that is about doing the angles of elevation and depression. And drawing these pictures can be the hardest thing about it. So that's the main thing I want you to focus on here, is making sure you can draw the pictures. Before you watch me draw the picture, please you try to draw the picture. Okay, now let me just tell you, if you haven't tried it yet, a technique that I think might help. Now, there's not always, like some of these, most of these problems, someone is looking up or down at something. Someone is looking down off the top of a building at a dog walking across the ground, okay? Or someone is looking up at a bird flying by, or a hot air balloon up in the sky. Something like that. And the looking part, the line that their eyes would make, which we usually make dotted because eyes don't usually make an actual line. It's kind of like if you had laser vision, or the person in the balloon had laser vision, where you would see the path that their vision is traveling. That's called the line of sight, and most of these problems have a line of sight. Okay, so what I want to suggest you do is you take that line of sight, you figure out where it is. Let's say I'm in an airplane and I'm looking down at the ground. So here's my line of sight. You take your line of sight and you make it the middle part of a big letter Z. Now your letter Z might be a regular letter Z, okay? Or it might be, here's regular letter Z, or it might be a backwards letter Z. But whichever way it works, you want to make the line of sight the middle part of the Z. So in other words, I have, this one's going to be a backwards, just because a forwards one wouldn't work. So there's my letter Z. When you have made the letter Z, the little corners are the angles that we're worried about. Those are your angles of elevation and depression. In this particular case, this would be an angle of depression up here. This would be an angle of elevation. It doesn't even really matter a lot of the time because they're the same. So like, let's say you were told there was an angle of depression of 30 degrees. That means down here is also 30 degrees. So that's where you put your angle in the triangle, is right there. That's what most people have trouble with on this. So let's go ahead and see what we can do with that. Now, number 1 on this page, I want to skip, ironically, just because it's not put in the same terms as the other one. So let's do a couple of other ones here. Number 2, a helicopter is hovering over a landing pad. It's 100 meters from where you are standing. Okay, so here is me standing. Helicopter over here. Okay. It's hovering over a landing pad, so it's directly above a landing pad, and the landing pad is 100 meters from where I'm standing. So that means this is 100. The helicopter's angle of elevation with the ground is 12 degrees. This is where we get into the line of sight thing. Is I'm looking up at the helicopter. Here's me looking up at the helicopter. That's the middle part of my Z. So here's my Z. And remember, it's the little corners of the Z that's where the angle of elevation or depression goes. And you don't have to figure out which is which, because both of these will be the same every time. So the helicopter's angle of elevation with the ground is 12 degrees. So both of those are 12 degrees. What is the altitude of the helicopter? Altitude means height. Let's call it A for altitude. So this is what we're looking at. That's my picture. So for this angle 12, the line of sight is always my hypotenuse. The diagonal is always the hypotenuse in these problems. This is my opposite. This is my my adjacent. And I'm going to use tangent because I'm doing opposite and adjacent. So tan of 12 degrees equals A over 100. Tan 12 degrees equals A over 100. I can cross multiply and I get 100 times tan 12 equals A. Is A alone? It is. So now it's time to put it in my calculator. 100 times tan 12, 21.25 or 26, what was this? Meters. Okay, so 21 let's say 21.3. 21.3 meters is the height of the helicopter off the ground. Here's my answer. Okay, this is actually kind of ironic that these three problems, after I've said all this about line of sight, some of the other ones, these other three on the page, don't really have a line of sight per se. But remember, the line of sight is still like your diagonal. So let's look at number 1 now. A tree casts a shadow 21 meters long. So here's my tree. The shadow is 21 meters long. Shadows are always on the ground. So here's the shadow. It's 21 meters long. Sorry, it's not quite level. Mine's a little bit lopsided. The angle of elevation of the sun is 51 degrees. Okay, pretend there's a line of sight. Basically, that's where the tree is cutting off the sunshine from hitting the ground. Okay, so the angle of elevation means I need to make my big letter Z. Angle of elevation of the sun is 51 degrees. What this is saying is that the sun is way over here. And it's shining down on that tree and casting a shadow like that. What is the height of the tree? So that's my X. Okay, so I have 51 degrees. This is like my line of sight. The diagonal line is my hypotenuse. This is the adjacent. And this is the opposite. Okay, so I'm working with the adjacent and the opposite, which is tan. Tan 51 equals opposite over adjacent. Cross multiply and you get 21 times tan 51 equals X. X is alone. Time to pick up the calculator. 21 times tan 51. And I get 25.93. About 25.9. So X is about 25.9 meters. I'm going to write it over here. That's number 1. Okay, I've decided that I'm making so many videos for you. Those people who are watching the videos should get a special reward. So I'm going to put some Easter eggs in the videos. What that means is I'm going to put some little things in the videos that you only notice if you're watching the video for real. So I'm going to give you some random words as you're going through this. So here comes your first random word. First random word, purple. Okay? Now, number 3. You are flying a kite and have let out 80 meters of string. Okay? This is one of the very few situations in which you will have a length for the diagonal, is when you have a kite problem. Because the string of a kite goes diagonally. Here you are holding the string. Here's the kite flying in the sky. Okay? The string is 80 meters long. So this is 80 meters. So we actually have our hypotenuse this time. The kite's angle of elevation. Okay, so remember the diagonal part, which is this time the string, is the middle of my Z. Sorry, again, my Z is lopsided. I'm so sorry. Hopefully your OCD won't kick in. 40 degrees is the angle of elevation. So that means here and here, right in the corners of the Z. Okay, if the string is stretched straight, how high is the kite? So here we go. I have to use my lopsided part. Straighten it out a little bit. So we want to know how high is this kite? I'm assuming the string is stretched straight because I'm not sure how you could fly a kite with a wrinkly string or a string that has some slack in it. That would be kind of weird. Okay, so here's the angle. This is the hypotenuse. This is the opposite. So this time we're using sine. Sine of 40 degrees equals opposite over hypotenuse. Cross multiply, you get 80 times sine of 40 equals x. And then I do that in my calculator. 80 times sine 40, sorry, punched something in wrong, gives me 51.42. So let's go with 51.4. And it was meters. So that is my answer. The kite is 51.4 meters above the ground. Okay, here's another one in which my diagonal isn't necessarily a line of sight. It says a 15-meter pole is leaning against a wall. The foot of the pole is 10 meters from the wall. So I'm going to draw my wall. Here's the ground. A pole is leaning against the wall. Then I think about where these things are. The length of the pole. This is the pole. So if it's 15 meters long, there it is. The foot of the pole, that's down here, is 10 meters from the wall. So that means from here to here is 10 meters. Find the angle the pole makes with the ground. This is a kind of a different one. We're looking for the angle between the pole. Here's the pole. Here's the ground. You got to go to where they meet, and it's this angle right here. This angle. That's the angle that the pole makes with the ground. I'm going to call that x. So remember, when I'm trying to find angles is the only time I use inverse. So first I set it up. I don't really care what I'm going to use, inverse or not inverse, when I set it up, by figuring out which is the hypotenuse, which is the opposite, and which is the adjacent. I'm using adjacent and hypotenuse, so that's cosine. So cosine of x equals adjacent over hypotenuse. This is where the inverse part comes in. To get cosine away from x, I have to pluck it up out of that side of the equation and plop it down on the other side, and moving it across the equal sign makes it turn into an inverse cosine. So in my calculator, I will do inverse cosine, second cosine. You get that little -1 of 10 divided by 15. And I get 48.18. Usually with angles, we round to the nearest degree, so that's 48 degrees. Okay. Next one. We have Jeffrey determining the height of a building. Okay. He takes advantage of a nearby fire hydrant and the shadows that are cast on the ground. If he is doing this at the same time of day, okay, assuming, in other words, that he looks at the fire hydrant and then goes to work with the building immediately, not he looks at the fire hydrant at 9 a.m. and then goes to the building at 3 p.m. We're assuming he's looking at these things at the same time of day. That means the angle of the sun would be the same. So that means the angle of elevation would be the same. That's why they're both the same letter, Z. Okay? And that implies that these triangles would be similar. Okay, they would have the same angles because they have the same angle Z. They both have a right angle right here. Remember, angle is enough to say that two triangles are similar. If they have two angles the same, the third one would have to be the same, because if we subtract from 180, whatever Z and 90 are, we definitely get the same thing. So the fire hydrant, so I've got two similar triangles, so I can compare these triangles. The fire hydrant is 26 inches tall. The shadow cast by it is 17 inches long. The shadow cast by the building is 25 feet long. Here's the height of the building. I'm going to use similar triangles. I don't even have to use trig. Okay, I really can't use trig at this point. In other words, I'm going to set up a proportion. This over this equals this over this. That's how similarity works. Okay, so the bottom part over the bottom part. 25 over 17 equals the height over here over the height over here, h over 26. So I can cross multiply to solve this. When I cross multiply this, I get, I think 25 times 26 is 650. Yep. 650 equals 17h. Now I divide both sides by 17. And 650 divided by 17. I don't know why I'm pressing so many wrong digits today. Gives me 38.2. So h equals 38.2. All right, so that's part one. Determine the height of the building, h. Round your answer to the nearest foot, so that's 38. So 38 feet. Okay, I showed my work up there. If I had realized it said show your work or explain your answer at that point, I probably should have gone ahead and done more explaining, but I'm explaining verbally. The next part says, what is the value of z? Okay, we can use, if these two triangles are similar, remember we said z has to be the same. So if we know that this is 38, we can really use either triangle to find z. I'm going to use the one on the left. I don't know why. I just feel like it. So if you use the, if you use the one on the right, your answer might be slightly different from mine because that 38 is rounded. But I'm going to use the bigger triangle. And I redrew it. And here's what that looks like. That's the building. And so this is the hypotenuse, adjacent, opposite. I'm going to use the opposite and the adjacent, so that's the tangent. So tan of z equals 38 over 25. So inverse tan of 38 over 25 gives me z. So inverse tan, that's second tan, 38 divided by 25. And I get 56.65. Remember, with angles, we usually round to a whole number of degrees, so that's 57 degrees. And that's my answer. I'm going to give you your second Easter egg word here. It would be the word cows. Okay, that's the end of this one. And next, you might want to try the extra review that I'm posting and look at the key for that.